Okay, who pulled this one up?
That's me. I'm on Zoom. Hi.
Ooh, nice. Okay, if you just want to, let me turn the volume up, just talk over it a little bit. Or
Um,
if you're on Zoom, if you want to share your screen, or if you just want me to sit on this photo and you can talk.
I'll just kind of briefly explain it. So basically, this designer, John, I'm not going to try to pronounce his last name. He created these coral reef lamps by developing a computational design algorithm that mimics the growth of patterns found in the natural environment. All of these lamps are 3D printed in the USA, and they use like recycled material, so they don't waste like as much. In the manufacturing process. They did like hundreds of prototypes and models, and then they kind of just ended up on three main designs that they're kind of moving forward with and developing for sale. But I just thought it was really cool how they kind of did a lot of studies on these coral reefs to mimic the natural kind of elements of them. So yeah,
Cool.
that's
Yeah,
it.
thank you. Yeah, with computational design, we can do a lot to like mimic natural things. So we'll get into some of this type of stuff in the class, which I'm always very excited about. So cool, thank you.
Mhm.
See the next one. Oh, also, if you know how to change your name in Discord, that'd be cool for, I guess, for everyone.
I got you.
I know Grayson, I got that one, and Barbara and Avery. But yeah, the nicknames sometimes they confuse if we're doing stuff back and forth. Um, okay. Okay, is this one yours?
Yeah,
Nice.
mine. So I studied a lot of topology optimization last year for my graduate thesis. But really great for additive manufacturing because it uses design and mathematical calculation to create this optimized piece, which saves a lot of material inherently. You get these really cool bio mimicking almost parts that you see in nature. And that's really great for multiple reasons, like production lines, engineering, like lightweight parts. Um, it's really cool, kind of like design and
These are pretty fun, and I mean, there's other tools like Nthopology or Fusion 360 that might still offer this optimization stuff. Um, it's neat. We won't play with it too much in this class just because there's ways to do it in Grasshopper, but you need a GPU to do this type of stuff, and my laptop doesn't have a GPU card, like a good one. So, but yeah, this stuff is super neat. So thank you, Kay.
easy, but it's
Ah, nice, nice. Okay, we got Grayson in here.
Oh, yeah.
Yeah.
So,
Oh wait.
I study neuroscience with architecture, and there's an annual international neuroarchitecture conference that I'm attending in like 2 weeks, and so I, I told my professor so that I'm going to be missing in like a month at a time. And so he proposed this was as something I can do instead. So, this was, I guess, my documentation from like a panel of three individuals who spoke about like what the research is. So the first one's like design for neuroplasticity, which is our brain constantly changing and stuff like that, and allowing it to change. The second one, which is where it's on now, is kind of like essentially measuring. So in the middle of my sentence, currently your brain's already gonna automatically try to guess what the end is gonna be. And we do the same thing when we're transitioning between spaces. So the idea is maybe if we can alter design to uh, lower the wrong predictions, because we can see the incorrect predictions go the opposite way, so we know that the brain predicted incorrectly. So maybe how design can affect that. And then I think the last one was of this was over the summer. The last one was like how much people remember during their sequence of going through like space or building, and also activity in the brain when doing such. So I think the more complex an area, the more activity, but the less but less people will actually remember when re-experiencing the first like 3 seconds of the experience, whereas if it's more simple, they're a lot more likely to remember the sequence after experiencing the first two. And so I guess if you're interested in reading more detail in any of them, that's that.
Ooh. So this is in a architecture type of space, like understand the brain to then create architecture.
Yeah. Yeah, I mean, there's a few ways to look at it, like what happens in the brain of the occupants, or like even what happens for the architect or design process. But mostly it's going towards the occupant.
Okay.
Yeah.
Yeah. Neat stuff. So you'll have to tell us about it when you get back. If you want. But cool. Yeah, awesome. Charlotte in here online.
So I know like the shoe one is kind of common and like we've talked about it before, but I think this article just basically talks about how, you know, with 3D printing, it like saves on waste, like 20% of all shoes like go into like oh joy. Don't worry about it, it's not worth it.
It's not.
But yeah, and it's basically how it saves waste. The shoes can be recycled at the end of their life, and then this leads to more manufacturing in like the US or Europe compared to Asia. And that's basically what it's about.
Cool. Yeah, so is it on multiple different companies in here?
Yeah, they talk about quite a few. Remember which ones, because I like did this, you know, a little bit ago, but
I mean, yeah, the first one up here, the Zellerfeld print, that's a new up and coming company that just released like open data for designers to submit designs and then have them 3D printed in Germany to be shipped out across the world. But these are super cool. You know, once you are done using the shoe, you can send it back, they'll recycle it and print you a new pair, which is pretty neat. You haven't seen the Puma one. But yeah, this shoe's pretty cool. I forget the designer's exact name. I don't know why they're not listing it here. Yeah, but I know the designer of this on Instagram, and he put this pattern on after a workshop that we did, which was kind of funny. That's a neat shoe. But yeah, there's a lot in this article actually about different kinds of shoes. But cool. Thank you, Charlotte. Okay. Yeah, we're gonna get rid of this one specifically. It's only like a couple. That is impressive. I usually have 100. Who did this one?
I did this one. Sorry, I'm on Zoom.
Perfect. Cool.
So I found this chair by this guy named Patrick. If you scroll like through the pictures, yeah. So
Yeah.
he started out with just like a basic form for making like a foldable chair. So it actually folds up completely flat. And then he used like computational design to make it more visually appealing.
That's a nice chair.
That's a nice chair. Do you know if the actual seat is flexible? Kind of looks like these are rigid parts, but they're kind of tessellated in a way that fabric.
I'm not sure, but it looks like they can move. Like it looks, I'm not really sure, but yeah,
Wow.
the individual pieces look like they're joined to be able to move.
Do you know what the materiality is?
I'm not sure. I didn't really look into it that deeply, but I would assume like plastic.
Yeah.
Yeah. Yeah, if it's Dassault, it's definitely a big company sponsoring it, but it's probably like an SLS powder bed laser sintering approach for something that's highly detailed. Like there's no layer lines at all, so it's not an FDM style. But yeah, this is super interesting. There's in terms of the folding pattern, there's a design studio called Nervous System that did something like this, where they made a dress out of really tiny triangles. There's like thousands of the triangles, but it's printed in a little ball, and then you can like unhinge all the triangles to get a full dress, which is pretty neat. And they did that in collaboration with a mathematician at MIT who like researches folding patterns. So I think we probably went over that last semester in the same course, but yeah, they're a cool studio. So thank you. That was a nice article. We have this next one here. Okay, make sure to disable cookies, everyone, that are not necessary. Who did this one? Was it? Yeah.
Yeah. So it's just about electric violin. It's been a violin back. Made out of and I wish I could find how it sounded. I would put it in there, but I'm really interested how it sounds.
But since here, it's probably made of natural wood and it's been from carbon fiber.
Yeah, that's the
So
The neck and stuff.
Okay.
Interesting. I'm assuming it's an electric violin if it's not like the acoustic.
perfect. So
I mean, maybe, yeah. No, the body's super interesting, and we could easily do something like this in this course, with the type of pattern that they made for a violin. Might be a cool project you'd look into in the future if you want to do, like instruments. It's a very, very nice design. I've seen guitars and stuff like this, similarly as well. But it's definitely on a big scale with printing. Same as kind of like the chair. It'd be hard to do it on like a desktop machine, but unless you're doing it in multiple parts. But yeah, this is a super cool project. So thank you. Okay, Avery. Cool.
So this is like combining and I'm just really interested in like visual design to create like kind of flowing like structures and especially like the idea of like integrating things like the visual structure is like acts a little bit different. I think it's like generally I'm really creating these like fun organic
Yeah. Yeah, this is a nice project because we could easily look into like minimally curvature surfaces and then actually like plotting curve patterns on top of that to like mimic a sewing pattern. And you even get into if you wanted to actually do like set up knitting commands for a knitting machine, you could do all that in Grasshopper too, and then send that off to like a digital knitter. I don't think we have a digital knitting machine, but if we did, I worked with them before, and you can set up the process to like do it, which is pretty nice. Because that's not like hand knitting, which is impossible to do on a machine.
Right.
But digital knitting was like getting all the needles or the little fingers to all, pull the correct threads and stuff. So you can set the patterns and everything in Grasshopper and then export it. But yeah, this is a neat project. Thank you. Is this next one different?
It is but
I mean, if you want to, but Mohammed?
Yes.
Cool.
So this article sort of like highlights what the future of architecture could be if it like starts embracing technology more. And I remember when we were doing like some project where we had hand draft for the first few weeks. And when I started looking at like what article I'm gonna put for the homework, I came across this article and I was reminded of like AI languages. And I was stuck in my web, and after this I started using AI. I had a better idea of like how to move forward with my project. This article sort of talks about like how the construction industry always behind comes to technology, unlike like other disciplines. And something that I like agree with a lot. Part of the reason.
Yeah, I mean, it is hard to innovate with every project costing millions, and especially facades like this being super unique. It'd be hard to do like a full thing unless you had a lot of money. But I mean, there's definitely buildings like that, you know, try to mimic this before AI was a thing. But yeah, a lot of this now coming out is super neat to see. And parametricarchitecture.com is like a site that does a lot of news on AI type of generated art for architecture like this that has a lot of cool images, and they do courses on Mid-Journey for architecture as well. Might be something cool to look into. Okay, Izzy? Yeah.
For like function like lighter than regular concrete, using computational design to optimize based on strength, and it helps cut down excess material and like offer more cost.
Nice. Yeah, I was wondering what was happening because you can see the layer change as it gets about this middle part. But yeah, it's cool to see a 6-axis robot being used for liquid deposition modeling like this. Yeah, if this is something anyone's interested in, we have some small robots up by the 3D printing lab that we have clay extruders on that we could do, you know, small scale models like this. And you can do the tool pathing in Grasshopper, that you can define the curves and then send that to the robot straight from Grasshopper. So Grasshopper is pretty powerful. Like we can program robots with it to 3D print if you really wanted to, and then make something like this. But yeah, thank you. Okay, Lewis.
Yeah, so this is
Mhm. Yeah, this one's super neat. I don't know if you've seen any pictures of it recently. But I mean, yeah, this project is a few years old. But yeah, it has decomposed, and now there's just like the skeleton wherever they have it exhibited. It's not at MIT anymore. But yeah, it's just that white skeleton, and the chitin has all dissolved through the weather over time. But yeah, this one's neat playing with organic matter, just like with the liquid deposition we saw in the last project with clay. They were doing a similar thing with chitin. So like the biological matter, like seashells. So if you have chitin at different hardness levels, you can do like really hard stuff like fingernails, all the way up to really flexible stuff, kind of like skin or something on the far right-hand side. So I think they used a robot with multiple extruders to do different hardnesses of chitin. So they could map like the structure of the leaves and then go back and fill it in with a different kind of material. It's all the same material, but it acts differently in the print. Which is, yeah, it's an amazing print, and Neri is awesome. Okay. But thank you. Yeah, this is a neat project. I saw someone else did a Neri Oxman, a death mask, which we'll get to. Oh, you did that one as... Okay. Yeah, I forget exactly what the death masks, like the process of it. I know they were also reactive where they printed it, but then I think if someone like breathed into it, then the biology would kind of change and you could see it move. If someone else wants to see it, that'd be cool. Yeah. Yes. Thank you. Okay, who is the cool brick?
It was me.
Nice.
Yes. So that comes from the same concept as the clay stampede that we saw earlier.
Mm-hmm.
But this is actually brick, and the whole purpose of it is that it collects the warm air from the outside, cools it on the inside, and then lets that cool air back into the environment to the inside.
Mm. And
yeah, that's pretty much it.
Nice. Yeah, it's cool to see how you can mimic like micro lattice structures on an architectural scale.
Yeah.
if you zoom into most like insects, like if you zoom into a butterfly's wing, it kind of looks like this at a microscopic scale. It's not, cooling it down or anything, but a lot of these textures are found in nature. So it's cool that we can reproduce it.
Yeah, I saw an example about a year ago that it was that and it was a bunch of bricks, but you could also have spaces for microorganisms to grow also inside of that and create like he created like it was I think it was an AI generated image, but it created like this small on top of bricks, clay bricks like those. But I couldn't find that prototype on that project.
Yeah, that's another cool use case. Because you can also do this for if you want to repopulate coral, like coral reefs.
Yeah.
They usually do this with concrete and then drop that in as a way for fish and other animals to like latch onto. They also do this in a medical scale for 3D printing. We kind of saw it with K's on some of the EOS parts at the end. But this microlattice structure, if you put it in as a bone replacement, the bone can kind of grow into the part, and it has a better hold than traditional stuff. So,
do they have a patent on this?
oh, do you want to copy it?
No,
No, you could look into it. Yeah, it's a good question.
Isn't that even like exactly like this?
Yeah, like if you could put like metal meshes underneath, and sometimes you have to do stuff like that. Yeah, definitely. Give me 1 second, I'll reshare the screen. Hey Henry, you there?
Oh wait, am I not muted? Yeah.
Oh, okay. Thank you.
Sorry.
Okay. Nick, wait, yes. Nick, you're on Zoom, yeah?
Yeah, I'm on Zoom. Hopefully you can hear me.
Yep. Yeah, we got you.
Yeah. So I found my my article is another small one about parametric architecture and kind of some examples in the recent past about how the use of Grasshopper is becoming more and more used in the architectural world and how it's being used in some really awesome, cool examples of precedents of how these types of programs, these parametric and computational design is being used in facade and building forms and even some smaller structures in architecture. And I thought it was really cool because some of my favorite buildings are actually in here, and I didn't even realize that it was like Grasshopper. I just thought that somehow, some way, the architect did all of it by hand, even though that makes no sense.
No, totally. That's why it's good to have software tools like this to do most of the work for you. But it is funny. It kind of looks like this, which isn't anything fancy, but all the this is the most complex software you can use for computational design. So, you'll see studios like Zaha or Big, or some of the other massive ones using these to do some of the crazy designs. So, yeah, cool. Thank you. Aaron, is Aaron online? No. Okay. Becca. Cool.
So this one is pretty simple. It's just like 3D printing furniture. And I liked it because I like the gradient. I haven't seen that. The clay, like, because it's like the concrete. So I thought it was pretty cool. There's a lot of I thought it was really cool, and I thought it would be cool to see like its pieces or accessible furniture because it's just making it more ergonomic, but also still look cool. Yeah, they talked a lot about the challenge of having furniture like built like this because it's not very like structurally sound all the time. Like it needs like support. And so it needs a lot of programs to try to figure out how best to make it look cool and ergonomic while also.
Yeah, no, this is a really neat project. And yeah, I mean, you touch on the fact that they don't have any rebar in the concrete. So it says it sets as it will, but it is cool if you notice in here the little bumps on the inside to add more rigidity to certain parts that need it, and it's not just constant, it's kind of flowing in and out of the shape depending, because at the end you don't need much support. So yeah, this is a nice project I saw a couple years ago, and they might be piping in the color at the same time as the clay coming out. Because I've done some clay printing before and it's really tough if you're switching materials to control like when that color is going to come out. So a gradient is quite impressive. But yeah, they're using an ABB. We've got some small ABBs upstairs, as I mentioned, but we have one about this size out of RDF as well, if you know where that is. I don't think we've ever printed clay at this scale, but you can do some big stuff with that.
And what kind of
Yeah.
most
Concrete really does not like.
Mhm.
It's like it's that part of it.
just like
I mean, it must work, but it would.
It must.
Right.
Yeah. Yeah, there's a lot of ridges and texture in the whole thing. I don't think anyone put this in, so I'll bring it up as well. But there's a company, Nagami, that does a very similar thing, but this is just with plastic in a similar robot. The thing of Ross Lovegrove. They have a chair collection though that looks similar. There's one of them, but yeah, more like these ones where it's not concrete anymore. It's more stable plastic that they're using. Yeah, these are cool. But you can see like the multiple axes as the robot moves its head more than a traditional 3D printer can, and then the color change as well. It's super nice. So I feel like these would be a little more structural. Yeah, cool. Let's keep going. Austin. In here? Yes.
It's like a large format, out of the. This SLS or SLS.
Selective laser. Okay.
But it's for, it's like a special aluminum alloy. They used it. Oh, I guess that's.
Might be the company. Yeah.
But anyway, they used it to make a like fancy roll cage for a solar car. So there's a competition called the World Solar Challenge that Bridgestone does.
Mhm.
These cars that run purely on solar power. So like, all of the driving they're doing, they're getting from I can make them hyper efficient if I can get as much out of
Mm-hmm.
we
Makes
actually-
sense. I was gonna ask if Tech has a team because I think I've seen it before. Do they run it out of the Maker Lab, whatever, in Goodwin, or is it in Randolph?
They just moved.
Oh, okay, cool.
Near the website.
Well, yeah, that's cool.
Pretty cool project.
Fun. Yeah.
This was like the bubble.
Ooh. Nice. Cool video. So aluminum for lightweight,
Yeah,
I'm assuming, and then optimized.
aluminum, silicon, magnesium.
Interesting. Cool.
It's ultra low porosity.
Hmm.
I'm not sure what that is. Yes. Like I know what it means. I don't know
Right.
what it does.
What it, like, okay. Which it might just be a 3D printing thing because like FDM prints are pretty porous. Like they're definitely not food safe if you FDM print a cup. Like bacteria can get inside the little layers. So maybe that's something they're talking about for cleaning. Maybe. Okay. Okay, cool. Sean, last one. I like your name. We got another shoe thing.
I don't know if this was exactly computational, but reading the article, it kind of seemed like they had used but they started like 3D printing shoes. They like started with prototypes in 2014, and I think The original one is that one.
Yeah.
And they would scan like professional athletes' feet around the world and see like where the pressure points in the foot, like when they're walking, when they're running, so that they can have the harder parts where there isn't as much pressure, but then softer parts where they're putting a lot of pressure on their feet, so it absorbs it better. And they ended up doing it, and the first pairs were selling, I think they sold them for like $300 retail or 400 or something. But they've been processing them more, and they're one of their best selling shoes now. It's like the Ultra Boost like 4Ds, but apparently they're really comfortable and one of their best shoes now. And they used all like these scans and 3D printing to print them. So,
Yeah, I really wanted a pair when they first came out, but they were like really expensive.
I think they're cheaper now. I think you get like
They're
$110.
cheaper now.
Yeah.
I was looking at it a lot, like even before it came.
Uh,
I was looking at it and I wanted to get a pair of them. I think I got like one of the first ones and it was ridiculously expensive, it was like those 300, 400 bucks.
Yeah.
And I have them here attached, so like I can bring them, but like yeah, also they were thinking about having like the 3D printers in some shops and that the people can like run on some surface and they'll scan like how they are running or like putting the feet on the ground and they'll be actually like for that exact person in the future.
So they're scanning while they're moving.
Well, they're not doing it now, but that's what they want to do in the future.
Cool.
There was an Adidas video that talked about the actual body structure. Find it.
Yeah, this.
It talks about that.
It's like unidirectional, where like when it is compressed, it folds forward, and then so like it's a bit more efficient.
Yeah, so it springs back to push you more, which is a really cool addition to the original. Because if you saw the original, it's just the pattern. Like there's nothing to this for the most part. And after Thanksgiving, we'll do a workflow like this where I have like scans of a foot. We'll put them into Grasshopper and we'll get this out of it. So we can do like a simple pattern, which is quite fun. So like remake something like this shoe. But yeah, they're working with a company, Carbon, that does all the printing. They're like a material scientist company. And then Adidas is with them to actually make the shoes. Yeah, these are cool because they push you forward. But the way they print these, actually, they don't print it like this. And if you've ever used a resin machine before, you know, you cure the resin with UV light and then it hardens into like a shape.
Really printed.
Yeah, so they print it vertically, but they also print it completely flat. So it doesn't have that bend in the front of the back. So there's two steps to the printing with this. First one is UV curing. So they'll print it completely flat with the UV, and then they'll put it in a mold that bends the sides up as it's super ductile. And then there's a second process where they chemically harden the rest of it. So then they harden like that shape into the shoe. So the flat printing is just for like speed and efficiency. So it's the same thing every time. And then they bend it like custom with the secondary process. So I think they're the only ones that have this kind of two-step resin material. Usually it's just UV and not the second part. So really cool stuff. I'll need to buy one at some point, but they're pretty cool.
And also they last longer than the Ultra Boost.
Oh, nice.
I know that like the Ultra Boosts are already and I just started using.
Okay, that's interesting because I would have thought like a resin printed thing might not hold up or it would get really dirty because there's like a bunch of texture.
How the newer
I can
one
believe it.
works, but I haven't this pressure was some problems, and I think they still work perfectly.
Interesting, yeah. Which is cool to see because we looked at the Zellerfeld article earlier, forget where it was, but those other shoes, I mean, they say they hold up a long time too under a lot of stress, and then you can just grind down the filament and print a new one. For resin, I'm not too sure because it's like a chemical hardening process where the filament's just a heat thing, so you can go back and forth. But cool stuff, everyone. Yeah, and then Lewis, there's a link in here, but 200.
Yeah, most of them are 200. Some of them
You can find for like maybe 160 sometimes.
I'm just looking at these.
Cool.
These ones, 160.
Yeah, I mean, there's some grants.
Oh,
No, school grant. So
Research. Get covered to running.
Good, good. A woman's 13. So.
I think you're going 6 Flags. You know,
Yeah. Okay, so we'll hop into Rhino now and take a look at actually modeling some stuff. Most of you have used Rhino before, maybe. I saw the form. I don't really remember everything. Never used Rhino, never used Rhino. Cool, 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 cool. Shouldn't be that difficult. My first year's picked it up in a day, so no pressure. Everyone's able to open Rhino? Yes? That's the first step. When you open it, it's probably looking, question? You don't have Rhino at all? Are you architecture or engineering students? How'd you do it?
You can either buy it for $100. You can get a free trial.
Okay, so I would recommend the free trial currently. Yeah, if you go to rhino3d.com, you can download it over there, and if you put in your email, you can get a free 30 days, and that should work for today and for the next couple classes. And then if you switch out your email, I think you can keep getting it. Yeah, that's what I'd recommend. Yeah, you'll come to realize everything is named after an animal in this class, so you get used to the animal names. Okay, we'll circle back when you get it downloaded. But for everyone else, when you open it, it's probably looking like this. Someone's got Grasshopper up, which we'll get to that, but thank you for being ahead. I usually work in perspective always. It's up to you, it's a preference thing. We have top, front, and right, but they're all locked in this plane, so it's kind of hard to model like 3D. You could draw like curves and then extrude from there. But I'm going to go straight to perspective and just start modeling in that scene. So we can double click on any of the names and it'll just blow up that screen to be the full thing. So I'm just going to have perspective as the full view. We'll talk a little bit about the software up front. So, main stuff to save the document, we have the save tools at the top, same in the file, pretty standard stuff. For moving in Rhino, we can do everything with the mouse if you have one, which, if you have a trackpad, it might be a little difficult. You can do it, but having the mouse is recommended. So with the mouse, the main first thing is orbiting, just like any 3D software. So we can look around the whole scene. That's just with the right mouse click, we can orbit. If you hold shift while doing the right mouse, we can pan around, so we can go left and right. And then with the scroll wheel, we can zoom in and out. So just basic movement stuff in 3D. You'll get used to it as we go around, like how to move around pretty quick. So the next thing to look at is the toolbar on the left side and the toolbar on the right side, which I'll move these guys out of the way. On the left side, we have a lot of drawing tools. We've got points, curves, solid objects, some operators. On the right side, we have things like color, layers, like if you have worked in Photoshop or something, we can put different objects on different layers. Materials for rendering and other things, which we're not going to touch, but having the layer panel open is what I usually do for organizing a scene. So on the left-hand side, we've got the basic tools. So we've got a point, which you can probably imagine what that'll do. So we can left click on any tool and then drop it with left click in the scene. So I've got a point now. With the point, I'll explain the gumball, which is going to be the movement handles in Rhino. So this might not come on for you if you first select something with a new build of Rhino. But at the very bottom, at least on Windows, on Mac it might be somewhere else, but at least on Windows at the bottom, we can turn on and off the gumball. So the gumball is just going to help us move stuff around the scene. So it's good to just leave this on all the time. And what this tool has, we can translate objects with the arrows, so we can move stuff in the X, the Y, and the Z direction. You can also move objects by just clicking on the object in the middle itself and moving it by hand. But if I drop this and then orbit, okay, it didn't go 10 miles away this time. But yeah, now it like went all the way to the side. So I would recommend just using the arrows instead of like pulling the part, because it might not go where you think it's going. So for translation, we have the arrows, but we also have these little grids that come up as well. You'll notice this one is blue and red to go in the Z and the X direction. If we orbit around, now it's green and blue, so we're going Y and Z, and then top down we have green and red to go in X and Y. I would always recommend moving stuff with these handles. It's a lot more specific. You'll know it's only moving in 2 axes, although it might take a little bit longer. You might have to move a couple times to get it exactly where you want it, but it'll save you a lot of time in the long run to move it with the handles. We also have rotation. So with these semicircles, we have the X, Y, and Z. So with the point, we're not going to see any rotation. But if we get out something like this polyline, so the next tool, we can draw just with left clicking, we can set points in a line. And then if you hit enter, it'll put that in, and now we have a line. So with this one, we can actually see the rotation tools as we go in the different axes. So that's rotation, and you'll notice that the gumball is resetting every single time to always be like locked to the XYZ once I let go. So right now it's not straight, but if we were to click off and then click back, it's back to standard view. And there's 2 more things we can do with the gumball. One of them would be scaling. So there's these little tiny squares at the boundary of every single shape. So the green one is pretty long, the Y, but we also have an X on the red and a Z on the blue. So we can scale stuff with these handles. So we could do it just in a single direction, or if we hold shift, we can scale it uniformly, bigger or smaller. Also on the X a little bit. And then the last thing we can do is, you'll notice inside of the arrows, there's little circles as well. These are like extrude handles. So I'll use the X-axis one. If I click on the circle itself, so not the arrow, but the circle, it'll actually extrude that curve into a surface. So now it has like 2 dimensions to it. And we can Command Z and do that maybe on the Y. That's pretty flat though. Or on the Z, but again, we're going to pretty much see the same thing. So I'm going to go back and do that on the Y again, or on the X to actually give some 2D-ness to it. So now we have like more of a 3D object in the scene with those extrude handles. So that's most of the gumball options, but you can play around with it to really understand what all the different components are doing, but basics are translating, rotating, and scaling. Right now, the surface I have is still transparent, so I'm going to touch on the next like UI thing about Rhino. Next to the perspective button that we clicked earlier, there's also a drop down, and this will show us a bunch of different shading settings. So currently I'm in wireframe, so we can only see the edges of the objects, but I personally like working in shaded at all times so we can actually see the surfaces, so it doesn't just look hollow. So we can turn on shaded and see all that now. Your background might be more gray than mine, but we're still in the shaded. I just made it white at the back. Okay, so does everyone understand how the gumball works? I was kind of getting that.
Quick question.
Yeah, Nick, what's up?
For the kind of floor of the scene,
Yeah.
is it possible to not have that look like that?
What would you rather it look like?
Just like, is there like a solid gray option or any other that's not just like a billion little pixels constantly dancing? Or is it just kind of stuck on that little?
Yeah, there's not like a solid gray option, but what we can do is remove it and just take it away, which might also be nice. If you want to do that, you can. So one thing I haven't touched on yet, but there is a command line at the top of Rhino. Instead of selecting a like a tool, like the polyline, you could just type in polyline, hit enter, and it'll give you the tool. In this case, you can just start typing in grid. And once you hit enter, it'll show up with a bunch of settings. And if you really want to turn the grid off, we can just put show grid to no and it'll take it away. So that's one way to do it. And then I can just hit escape to get that command to go away. Is everyone good over there? Okay, so that's the, I guess the first three tools. So the cursor, the point, and the polyline. You'll also notice there's a little drop down for every single tool. So there's just different ways to draw the same tool. So I could do a polyline, like starting from the midpoint if I really wanted to. But you can play around with that if you want. I'm gonna move on to curves now. So Rhino was like invented around the idea of a NURBS curve. So like a mathematically based way to create a curve in space. In the examples I showed, they'll be based on certain points that we set. So just like the polyline setting points, we can set points for a curve. There's two options here. So the first one, the control point curve, we'll pull that out and I'll show you what this one does. So same with the polyline, if we use the curve tool, we can left click to set a point. And then as we set more points, we can see there's a curve now in the scene. The only thing is it's not locked to the points I'm setting. It's kind of in between them, which again is preference. I don't really like this tool because I can't see exactly where I'm setting the curve, but up to you. The second one though is the one I like a little bit more. So same idea, we can set points, but now the curve is going to be locked to the points I'm setting. So if you hit the drop down, it's just the second tool right here is this one. So we can set a lot of points. And one thing about any of the curve tools, if we go back to start, it'll like complete the curve and make it super smooth. So you could leave it open like the one I did over here, or we can complete it and this would now be a closed curve versus an open curve over here. So that's the curve tools. Again, like the gumball still works the same. We can move, we can extrude, all that stuff. Everyone get the curve tools? Cool. So the next ones are going up another step. So actually designing some geometry. With the first set over here, it's going to all be 2D stuff. So we can make a circle starting at the radius and then going out, or starting at midpoint and then going out to a radius value to set a circle. You might also notice as we're modeling, I'm going to pull up an ellipse next, but if we see the command line up top, whenever I select a tool, it's going to ask us to do something. So if you're ever using a tool and you're confused about what to do next to actually complete the tool, you can look up at the top. So right now it's asking us to do the center of the ellipse. So I'll left click to set that. So now it's moved on. It's asking me to set the first axis. So I can go set that radius. And now it's the second axis. So I can set that as well. And then there's no more. So we finished. So now we have an ellipse that we can use in the scene. So we'll see how this command line comes into play with some other tools as well. Some arc tools, if you really want to play with those. To draw arcs. Kind of cool. And then some more polygons down here. So we have the rectangle tool or the square tool, depending how you think about it. If we can hold shift, it'll lock that. If we don't, it'll be a rectangle. So we can set rectangles. And then we get into some polygons. So this one has a couple more steps to it. So I'll just use this basic polygon tool, but we can see at the top now, it's asking us to set the center of the inscribed polygon. And if we read a little bit more, it's saying it's going to have 12 sides. The mode is inscribed. And then we have a couple other buttons, which we could click or not. So before I set anything, maybe I want to do a dodecagon with 12 sides, but maybe I want to do a hexagon. So we can click this and I'll set 6 for a hexagon. Now it says 6. So when I draw it, we'll have 6 sides. And we could hold shift to lock this on the x-axis or the y-axis as well if you really wanted to. Hexagon. So I'll left click to set that. No more command lines, so we're done with this command. Okay, so before we move on to like actual 3D shapes, one thing I'll mention is if I click on this polygon, when I do it, we'll see these little points come up. At least they should. Someone let me know if they come up when you click on a polyline or a shape. They do? Okay. There's another tool to turn on control points if you need to, but if they're coming up, that's good to see. So after we've drawn the shape, we can actually move the point itself. So now we could take the shape out of the 2D plane and actually start affecting the points a little bit more in 3 dimensions. So just something to know. And we can do this with curves. We can also do it with 3D shapes. We can move the control points to change it after we've drawn the basic one. Yeah.
So if you draw a shape and then a little ball on the thumb ball.
Yeah.
Extrude it. And so that creates a new entity that's separate from this.
Yeah. Okay. Yeah, it's a good observation. So the sketches are never like consumed by the next operation. So the sketch is always going to be there, at least in this like workflow, and then the surface is separate from it. You will notice though, this might come in. So there is a curve there, but it's being overlapped by the shape. So if I was to click around there, I have this little selection menu because it doesn't know exactly what I want. So it's going to ask me, because there's 2 overlapping things, to pick one of them. So I can either pick the poly surface or the curve itself. Just so you know, like if that comes up, there's multiple things that you're clicking on, so you can select one of them. Cool. Yeah, I don't like SolidWorks at all.
So many like companies love SolidWorks and they'd rather have.
SolidWorks is much easier to use because you're doing things that are rigid and convention, referencing multiple other
Yeah,
because you're that like relation.
Yeah, no, I only did one industrial design project in Rhino itself. Everything else I did was in Onshape. So I like Onshape a lot more than SolidWorks. They work basically the same, made by similar people that left SolidWorks. Oh yeah, so that's only if there is overlapping stuff. So it might not always come up, but so if I zoom out a lot and then like kind of click somewhere, it doesn't know what I'm clicking on because they're overlapping. So just something to note if that comes up for you.
I'm having problem with
Yeah.
the gumball trying to extrude.
Mm.
I know that that's like 3 topics.
No, is it just like,
I don't know if it's because I don't mouse today. Also, you click twice.
oh, you don't have a mouse, yeah. Okay.
Yeah, I
Good to know.
draw my mouse and when I opened it up, it didn't have the USB.
There you go.
Yeah.
Yeah.
Intersecting lines, that's not a thing in SolidWorks.
You could.
You.
It's not going to 3D print, that's for sure, but you could do it. Rhino's very free, which is most of the time bad. If you're 3D printing stuff, like you can't do like shapes that overlap and stuff.
If you export it as just kind of
like it'll make it a mesh, but if the surfaces aren't welded together, there's still issues. Yeah, if you're using Rhino, it's not made for 3D printing whatsoever, like SolidWorks or Fusion or Onshape is. I'm not saying they're made for 3D printing, but you always have like a solid volume, which is nice. Yeah, here we could just throw surfaces in and then send it to Cura, and Cura's gonna be like, what are you doing? But during the workflows, like throughout the semester, we're gonna go in, like every workflow I do is gonna be 3D printable at the end. So we'll work pretty cleanly.
There's called Super Slicer.
Mhm.
It's based on Super Slicer,
Mhm.
but it's got both time fix policy.
That's
You have,
nice.
like this stuff that'll like try and
Mhm.
just fill them with like its best guess at kind of what should be there, but just like make a line.
That's kind of cool. Okay, I'll look into it.
Python scripts inside.
Okay, that's kind of cool. Okay, so that's like sketch lines and 2D stuff. I'll take a look at 3D now. And then I might do services too, and then we'll hop into Grasshopper and go over some basic stuff. Okay, so yeah, going up from like 2D lines and extruding them, we also have surfaces that we could just generate straight surfaces. I'll look at this one, which is just the original one, which you can set a surface from 3 or 4 points. So I can select that command, put in some points, and then we'll get a surface off of that. So it's a simple 2D surface. With this one though, when I click on it, there's no control points that automatically come up, like with the curves. So there is this this option down at the bottom called Show Object Control Points. It's like this black curve with two dots on it, kind of at the bottom there. If you click on that one, it'll pull up the control points for the shape. And this will be useful for surfaces and then 3D objects as well to pull up the control points. So I'll click on this one and we'll get these 4 dots at the edge. So we could affect this surface as well. The control points will always be locked to the shape. If you want to get rid of them, you may have noticed when you hover over the command, each command is kind of 2 different commands, at least in this sense. If you hover over it, it's telling us that with the left mouse click, it'll turn the points on, and then with the right mouse click, it'll turn the points off. So when you hover over, we have that little icon for the mouse to show us which button does what command. So I could also turn the control points off if you wanted to. So both are done with the same button. Okay. How's that going? I don't know if questions on that. Okay, I'm going to look at the primitives now, and then we'll go into Grasshopper. So if you've used 3D software before, you're probably familiar with primitives. It's just like, if you use Blender or Maya or something, it's just like shapes that the software gives you by default. So it's going to be all the mathematical basic things like a cube or a cylinder or a sphere or a cone. And with these, they work pretty much the same as the rest of the commands. So we'll click on it. With the cube, we can draw the base first, and then it'll automatically do an extrude, and then we'll get a cube. So you could also do this. You could draw a rectangle and then extrude the rectangle. Same thing. This is just one command. We have cylinders, so we can draw a circle and then also give it some height. A sphere, so the center, just like a circle, the radius. Get a nice platonic sphere. And then it's got some other stuff like cones, torus. So the torus has 2 different radii, get like a donut shape. Got some good 3D objects. So that's most of the basic commands I use in Rhino on a daily basis, at least for this class. There is a few more if you have Rhino 7, it's specific to that. But they have sub-D tools in Rhino 7, which is like subdivision modeling. We can do it with the platonic shapes. Actually, well, you don't like sub-D? Maybe I'll give you some tips. So with Rhino 7, there is a sub-D tab at the very top, so we can get a different toolbar. I'm going to look at a sub-D box right now, the most basic one. So again, just like drawing the cube a second ago, we'll do a rectangle and then a height. And we'll get this kind of rounded off box with these different surface or like faces on it. Now to actually affect this shape, it's basically a cube, but we've rounded everything off. So we're working just with the box, but it just looks smoother. So it's really nice for modeling freeform geometry. So right now, if I left click on the sub D box, it's going to select the whole thing, which is not what I want. I want to like select that face and then drag it away to actually model this box into something else. So in order to do that, at the far right here, there's these selection filters. So once I turn on the selection filters, I get this other little box here. So at this point, clicking objects isn't doing anything anymore because now it's only looking for sub objects. So things like points, curves, faces that make up 3D objects. So in this one, I'm going to turn on the points, edges, and surfaces. So we get all 3 kinds of selections. So now if I click on this face, I can actually just select that face. If we want to turn this off and actually select the shape itself again, I can just disable it and then turn off the sub objects. And then we can select like the object itself and translate it around the scene. But I'll turn off the disable and turn back on the sub objects. And if you're not following along, that's fine. Well, we'll go into it more as we do some other things, but just to show what the sub Ds are, we can do a lot more free-form stuff, and the gumball still works. So if we extrude, we can get like other shapes. This will come in handy a lot if we're modeling like organic structures in the class. But I'll try to limit it because I know not everyone has Rhino 7. But you can do a very similar thing in Blender, which is a free software. You can do sub modeling and then just bring that into Rhino, and we can do Grasshopper stuff on it. Yeah.
It just does the normal view. I don't know why.
And you're
Yes. And I'll go with you.
So if you click on the cube just through. Yeah, there's a button for going between the 2 states. Let me see.
Yeah.
It's interesting. It's giving you all like hard edge stuff. Did you click the top cube? No, she clicked the top one, like the one that's right here. There is a way to switch. Oh, there we go. Okay. Yeah, so there's this like swap button up at the top, which I have it. Now it's in like the standard. So it's good to imagine like this is what I'm actually modeling. It's like no different than the platonic solid, just like adding faces to them. But what we're doing is just smoothing it out into a more organic shape. So we'll play around with this a little bit more throughout the semester with all the different kinds of modeling that we went through today. There's some good basic stuff. Oh, it's going to take a while. Yeah, I have so many plugins that it has to load. But I'll give you all some time to keep clicking and playing with stuff as I pull up Grasshopper. But we will hop into Grasshopper as soon as mine comes up.
Another way to subtract a shape from another shape by extruding, but I can't remember.
Yeah, it's right next to the cube icon, just to the right of it. You did a Voronoi thing?
It was just from last year.
Oh.
That is fully real.
I think next class. So that's a little more
There's
easy.
like acid in that. Trying to make something else, and it's just looking way cool.
Nice. Yeah. The Voronoi is really cool. But yeah, everyone uses Voronoi. Everyone that's touched like computational design is like, oh, Voronoi. Cool pattern. And then publishes it as their project. It's like, okay. You can only see so many. Oh, interesting. Well, that shouldn't happen. Good. Maybe. It's only been 2 minutes, but yeah, especially on this laptop. Yeah.
If we have to do it. And weeks of your life. Then after those weeks.
Hey. Okay.
Old computer that could.
But yeah, so the reason why it takes so long is because I assume with most of you, you're probably seeing up to display in terms of tabs that you have at the top. But I have more plugins, so it just takes a while to load everything. No, that's as many as I have. It goes down to W. I mean, we'll go through some plugins during the class, but like 6 maybe, and definitely not all these, but you have collected some. Huh? Yeah. Okay. I mean, most of them were like for projects, and then I used it once. It was cool, and then I haven't like taken it out. So, yeah, that's a good point.
Thank you.
Maybe. There we go. So let's look at some stuff. Okay, so when you pull Grasshopper, this is what we should be seeing. That's kind of like a blank canvas. I have stuff on here, but yours will be blank. Okay, we've gone through all the Rhino stuff. So yeah, Grasshopper interface. Left click does as you might expect. It'll select objects. The scroll wheel, we can zoom in and out of the canvas. The right click, we can pan around. I've had this typo for 2 years now. With the right mouse click, we can pan around the scene, and there's no orbiting. It's not a 3D view, so we can zoom and pan. Okay, left click and drag, we have the box selection. So the box selection is interesting. There's 2 ways you can do a box selection. You can start from the right and go left. If you do that, it'll select anything it touches. So it selects that box. You can go from the left to the right. So anything it only touches, it won't select. But if you go over the whole thing, so I'll go over both, it'll select the box, but not select the text. Right to left, even if I'm not going over the whole thing, it'll select both. So just different ways to do the selection based on which way you start. Good to know, but not super necessary. Okay, so the next important thing with Grasshopper is actually bringing in components to your workspace so you can start scripting different components together. There's two ways to do it. One of them could be if you know where it is in all of the tabs and all of the drop downs, you can go find it and put it on the canvas. Or if you know the component's name, you can double click on the canvas. You'll get this search bar that comes up. And if I want a line, I could type in line. So it kind of works like the Rhino command line, where you could type in a command and get it. Here we can type in a command. It'll do like a search of the most relevant options, and then you can click on the option you like the most. So I'm just going to get this line. Then I have 2 lines. Does that work for everyone? Cool. So double click to search. Where? In Grasshopper, or I spelled it? Where in the display tab? Oh, I don't know. Yeah. The guy who designed, I don't think he's British. His name's David Rudden. He might be British. Who knows?
He just likes extra powers.
He might, yeah. I have not noticed that. It's interesting. True. Okay. Okay, so yeah, if you can search up stuff, that's good. So next thing, Control Alt left click, Control Alt, and then if I click on a component, it'll tell me where that component came from. So it'll put up these really childish arrows and circle. This is all stock to Grasshopper, by the way. It's not like some weird. This is just how it comes. But it'll show you where the tool is. Yeah, it'll. Oh, funny. Oh yeah, once I let go, it'll like switch stuff. Weird. But yeah, that's good if you forgot where something is, or if you want to know like what plugin it's from, you can do that to get the component. Okay, so next couple things, which you've already seen. So we have the ribbon tab, which are all the different kind of parts of Grasshopper up at the top. Under the ribbon tab is the component sections. So each of these are a drop down that have more tools in them. And then on top of what comes with Grasshopper, we have plugins that we can add to Grasshopper to do different things. So I have this one called Dendro that does different stuff. And we'll get into like installing these and using them. Wait, which one?
No, I said you have the whole alphabet going on.
Yeah, I have multiple of every single letter. So nice. Yeah, every single one. So yeah, plugins, I'll talk about that next. So the plugins, we can find them in different tabs up top. But if you want to get another plugin, there's a website called foodforrhino.com. So there's a theme with animals, bugs, food. But yeah, you can come here and you can find every single plugin that's available for Grasshopper. Yeah, sometimes they mean stuff, sometimes they don't. I guess you could, but there's not that many plugins.
Getting to the really
Yeah, so they can just do things that Rhino or Grasshopper can't. Grasshopper, it can't do a lot of things. Like it can't read and write from an Arduino, but if I have this plugin called Firefly, I could get like a pulse oximeter on my finger and like measure my heart rate in Grasshopper. I don't know why you would want to, but you could. But you need a plugin to do that. So yeah, I mean, okay, if you're really talented, you could just straight up write Python code and make your own plugin to do stuff. But I can't do that, so I download plugins to do stuff. But there's some like Dendro, which I showed does like voxel based modeling, which we'll get into what that is, but we'll use this like pretty much every class. You actually might have Kangaroo in the list, which comes with Grasshopper now. It's a physics simulation engine. I got both. So, well, actually, this one's broken. It doesn't have everything. But yeah, Kangaroo 2 comes with it. It's a physics base, so there's like a solver, and you could do like mesh simulation or curve simulation. It's like a physics engine for Kangaroo or for Grasshopper.
I don't think some of these are working.
What do you mean? Which one?
We don't develop a lot.
That's not a word. I mean, we had to at some point. But yeah, in Food for Rhino, we can see like all the actually, this is not even close to all of them. Yeah, if you want to blow stuff up, it's a physics simulation. So
So you can do the physics simulation.
yeah, it'll shut up in Rhino. So yeah, there's 1,006 plugins. We'll do some of them, but you can see like the different. Well, I have Elephant. This one's really good, actually. Yeah, baking is a very important button. We'll get into why.
Takes what you have and it'll bake it your own season.
They should hire you. Yeah. But yeah, we'll actually look at probably like the top 6 of these, but we can see other categories, like dental, aerospace, architecture, clearly. Dental's huge. Yeah, Dendro a lot. Yeah. Grill. Oh, yeah, like if Invisalign, like each one is modeled to a certain person and then 3D printed. Yeah. So they probably do something in Grasshopper if I had to assume. Yeah, bunch of stuff. So could come here if you're stumped and get a plugin. That's what I usually do. Okay, yeah, but back to all these, we'll get into how to install those, I think, next class at the end. So these are all the ones that come with Grasshopper, leaving out Kangaroo. But we have first tab parameters. These are kind of all the inputs. So when you construct like a script, you'll see we could have numbers as inputs, we could have images as inputs, or we could have like geometry from Rhino as an input. So we'll look into that. The next one, so maths. So yeah, we'll go down and explain all these. We can do math stuff. Sets, so we'll get into like tree structure and data structure in Grasshopper. Vectors with points and directions. So curves, so like all the curves we were doing in Rhino, we could do the same thing in Grasshopper, but we could just define every single part of it. Surfaces, same thing. Meshes, again, something you can also do in Rhino. Intersections, so like Boolean tools and stuff will be in here. Transform, so moving things, rotating them, like all the stuff that Gumball can do, scaling. And then the last one, display. So if you want to give things colors or stuff, make them look nice, you can do that in this portion. Okay, so does like the layout of this make sense where you can find everything? Okay, so we'll go through like the theory of how Grasshopper works. So as I explained on the first day, like when we're writing scripts in Grasshopper, usually our aim is to, let the computer do a set of processes for us, so we don't have to do it every single time. So, with this, if I wanted to make a box, I got to turn something off. Hold up. Okay. So if we wanted to make a box, we could do this in Rhino. We just did it a second ago. A box. If I want to move that box, I could use the Gumball to move it. Or we could write a script that moves it for us. So, this is always going to move the geometry from the origin. It looks like 6 units in the Y direction. So doing that. And we can see how the wires are working, as we set up this script. So you have the original box will flow from left to right into the next component and then into the next component. So that's like how we're going to be working left to right with wires. It might not always look left to right. We can take this and we can move it down here, but I didn't change anything. I just changed like the organization of the document. But this isn't doing anything different than what we just did, even though it's not really going left to right anymore, but the wires are still flowing left to right. Something we can't do is circuits that loop back on themselves. So we have the box, we moved it. We have the moved box. I can't plug again that box back into the start, or it's going to throw this error. We can click on this error and see that we have a recursive data stream. So it doesn't know what to do with that. If you've ever programmed before, you know you can do like while loops or if statements, but that's really not something like with components that we can do in Grasshopper. So watch out for that. Okay, so getting in here, you'll notice that the move command I was using, it doesn't just have one input and one output. Sometimes they do, but this one in particular has 2 inputs and 2 outputs. With these, we were technically using the second input to give a vector of movement, but it just wasn't shown. This one I have it shown here. So we're moving 5 units in the X direction, but we can see that we can plug that into this second input here. And we'll see we have a box moved with it not. It's up there, but we could move it in the X direction. And we could put, you know, different things in here. So I could swap it. Now we're going up in the Z. If I replace it, again, we're in X. We could also, something to point out, you can have multiple things going into the same input. And we'll get into more of this in a second. But, you know, with dragging wires with the left click, that's easy enough to do. But we can drag multiple things into one input. If you hold shift, you can see a little green arrow coming up as I click shift. But we could do 2 inputs at the same time. So we get 2 outputs. We see we have 2 squares moving there. So that's something you can do. And you can also take wires out of an input. We can click on the output. And if we hold control, we have a little red icon coming up. We can go say, I want this one to go away, and it'll take that away. So that's, you know, some tips for putting different wires in. You'll see if I drag another one, it's going to kick out the first one, unless I'm holding shift to do 2 at a time. Another thing which I've been doing is showing and hiding different components. So right now, if you click on any component with a right click, we have this menu that comes up. You can turn the preview on or off. So off, we see nothing in Rhino. Turn it on, we can see it. We can go a step above just previewing it on and off. We can actually disable it completely, so it's not going to run like at all in the script. So right now the move is previewed off, but I can preview it on. But I can also disable it completely, and we see down the line no data is flowing since we turned this one off fully. So it's a couple things. I can turn it back on. And then, Sean, as you mentioned, we can also bake things. So if I come to this last component that I have and bake it, we can see now we have 2 boxes in Rhino itself. So now I can take these boxes in Rhino and do Rhino stuff to them. So just some stuff there. Yeah, and then to show this a little bit further, let's turn these off. Okay, so along with multiple inputs, there's also things we can do to the outputs of the inputs if we right click on the output, like here, if I right click on that output or on the input. It's different if I click on the icon. We have a different menu than the input of the output, so be careful where you're clicking. But you'll notice we have some more options here. We have reverse, flatten, graph, simplify, and all these, which we can use. So I'll show what these are doing here. You can see with this first one, we've set multiple values for the z-axis. So we're constructing points at those different places. With those points, I can draw circles, again, with multiple different radii. So they're all different sizes. We can turn them into points, and then we could turn those points into other curves. So now we kind of have this vase shape. Which I have all this, it's making it tough to look. Let's see. But I kind of want them there for the time being for some other things. Let me just yell zoom window and zoom in here. Okay, there we go. Okay, so with this, we can see a few different options here, depending if we do different things. So in one sense, and we'll see what this means in a second, but we have these 4 different circles, each with points on them, and then we're constructing another curve out of those points. These are all on separate lists, which we'll see in a second. So we can see we're just drawing 4 curves, but just to show what these other buttons can do, if I flatten this, then we'll see the curve is now connected all the way up. So it's taking all those points and putting them together instead of having them separate. Let's see, with this one, if we flatten these, now we get this kind of loop going around. So just know we have these options here to do different things to data, but we'll get into what data does right here and kind of try to explain this as best as possible. But this will make more sense as we go through different workflows as well. So I'll share this, and there's some links to other blogs that explain this in writing if you want to look at that later. But to show this preview. Okay, so right now, let's see. So we can see how data is structured, which is really important for when you're designing scripts to do multiple things without having to do multiple different scripts to do each of those. And we'll see how that comes into play as we actually write some scripts together. But with this first one, so we've got 2 sets of points here. This first one at the origin, and then the second one, which is 10 points going up the y-axis on the right side. So with these 2 points, we can see we have a list made out of these points. So the first one up here is showing us a list with a 0.000. The next one is a list of 10 points, and these are the points in space where they exist at. So we're x-axis 5 and then 0 to 10 on the y. So we can see x, y, z, how that's structured. So with this data, it's referred to as a tree, and we'll see the tree can have multiple branches. We'll see how that comes up. But up here we have a path, kind of like a folder for all this data to sit in. So the path has that name, so 0, 0. And within this path, we have all of the data contained there. So this one has those points in Rhino. Each of the points sits on its own shelf as well. So in this overall folder, we have different files in here. So we can pick the different files based on this, the index on the side. So 0 up to 9. So we have 10 indices. And we can call out the different points 0 to 9 to select different ones. So just kind of showing you how the data is structured as we start creating points in here. So we'll get into more of that as we scroll down here, but with those points, we can construct lines starting from point A, which is the one in the bottom left, up to point B, which is the 10 of them, and we can make all these lines. Okay, so now in this example, we have 2 columns of 10 points. And with these together, we can start to create a ladder. So one line that goes from one point right to the other point. In this case, the indices are starting to matter. So we'll see that, let's see, point 1 down here is connecting to point 1 in the other list. So if we look at this panel here, we can see how 0 is going to connect to 0. 1 will connect to 1 as we go across. So that's just for a single path. But if we had multiple paths, so now we can see, I've used some of the tools from earlier. So I've grafted one of the sets, and the other set we'll say is left being flat. So some terminology that we'll start to understand as we keep working with these buttons. But top one grafted, bottom one is flat. So we can see what that's doing in the panel. So the top one, we've put every single point into its own folder. And in the second one, each point is all within this one folder. So, if we create lines, again, from point A to point B, we'll have this structure. So all we've done is grafted one of them, but we can see these two, other than that, look exactly the same. So in this sense, what we've done is path 0 is now looking at path 0 down here. And indices 0 is going to connect to indices 0. But since there's 10 of them, it'll go through and connect to all of them. So, we could see with just looking at what's happening with this first path, we have all those lines going up. But we can go to the second path, third path, fourth path, and go through and see how these lines are flowing from the different paths. So that's just with one of them grafted and one of them being flat. We get a pattern like this. So what if they're both grafted? So again, we can see what the panels look like. But in this sense, now that we have two grafted lists, path 0 again is going to look for path 0, and then it's going to connect to all the points in that path. But since there's only one point in each path, we're back to a ladder structure. So we can see that path 0 is going to path 0. So same as earlier, indices 0 to indices 0. Now we're just doing path 0, and then looking inside of that, the first indice to the first indice. So it looks the same as earlier, but that's just because both paths now look the same again. And most of the scripts we do probably are not going to be this complex with like moving data, but it is good to know how it's working as a theory before we actually get into doing a workflow. Okay, so with this one, we can see again how this might be useful bringing in a loft to this, so making a surface out of lines. With this first one, again, we have two ungrafted lists, so they're both flat, and we again get this rung structure. And if we lofted between these, this loft tool is going to look at, what's at the first indices, so indices 0, and then it'll start lofting to the next indices as it moves up, and we can see we get this flat plane from that. I mentioned the indices earlier and how we can like pick an indice, and right here I have this selection item, and we can go through and see the different rungs on the ladder, calling out, say, indice 4 is going to be that line. So we can see like how these indices are working when we select them. We can come down to this next loft, and we can see that I've grafted both of the lists. So now if we look at the line and the structure of how the lines are set, we have one line on each path. So path 0 only has one line on it. So if I go to loft that, we're going to get nothing because you can't loft a line to nothing. It needs something else to go to. So that's because we did the same thing, but we just grafted them both. So now we have a line on separate folders. So there's only one thing now in each folder. But we can come down to this next one, and we can see I've made like each line have its own little loft to it. And what we've done, we still have the same grafted part. So each line is on its own path. But I've moved each of those lines up a little bit, and then inserted them back in to each path. So now instead of one line on a path, we have two lines in path 0. So now if we loft, it'll go from 0 to 1 and create a loft, but it's not going to go 0 to 1 and then to the next one because they're on different paths. So it's reading each path separately. So suffice to say all of this, what we could have done is we could take a single line, move it, do a loft, and we could copy and paste this whole thing 10 times. We could have 10 different scripts that do each rung separately, but that's 10 times more components than we actually need if we just have the data flowing in a way that makes sense for the computer. So we can do, 100 components in just these 10 because of the way we've structured the data. So as we do more workflows, we'll get into like how this is working. Because usually with CAD, you're not like thinking this deep into it. even though like when you're doing CAD, you would do all these steps. Like if you want to make this, you would draw the lines, duplicate them, move them, and you would do all those steps yourself. But we can write smarter ways to have the computer do that more efficiently. So it does not matter if you don't understand lists right away. This is like you've been using it for a year and you kind of start to understand how lists are working. It takes a while. But the workflows we're going to do like don't really deal with this in a large sense. So, but it's good to know the theory behind like how this is all working and how scripting is going to help us do something really complex in like simple terms. So we'll go till like 7, 7:10 or something, most classes. But the rest of this is just like showing what most of the stuff is within a file. Or I guess within the different panels up here. And we might get into some of this at the beginning of next class as well, so we don't go for too long. But let's see, I have all my stuff that I saved from earlier. So I mentioned, maybe half an hour ago, how you can reference geometry from Rhino into Grasshopper. This will be really important as we like do all the workflows because we'll use this pretty often. But under these two tabs, we have different inputs that we can use, and I have a couple pulled out here. But with all these, we can actually like grab something from Rhino and use it in Grasshopper as an object. So I'll do maybe this brep first. So, with Rhino, every kind of object has its own kind of data type. So the curves are curves or lines, points are points, meshes are like, some kind of mesh object. But mainly in Rhino, you'll be using breps, which are going to be like the primitive shapes that we made. Or in Rhino 7, a sub D would be a sub D here. So when you're importing them into Grasshopper, it's going to know which are which. So if I want to pull this cylinder in, I can grab this vrep, which again, if you type in vrep, we can get that, or we can find it in this list, but it doesn't matter too much right now. And we can right click on that component and actually set a vrep. So let me deselect it. So it's boundary representation. It's like a mathematical way to define a shape. Right, yeah. That's why they're pretty simple in here. But we can hit set 1, select it, and then now we'll see, it's in Grasshopper. We can light it up if we click on it. So if we move this object in Rhino, it'll be moved in Grasshopper as well. So we can have some control going from Rhino to Grasshopper and back. Next thing with the input, so we have sliders that we can use for number values that we can interact with on the fly in a definition. We have a lot of different inputs here that we can select from. Number sliders up at the top. We've been looking at a lot of panels. Those are up here as well. These yellow windows to see data. So we can grab those to set different numbers. The panels are special. You can write integers or strings straight into here. But you can also read stuff as well. So if we have something set, we can read it with the same component. We have some Boolean buttons that we can use for different things, true or false values. Some curves here that we can see it's actually affecting the numbers as they come out. So we can remap numbers with a curve. And what does this do? Ah, yes. Okay, so we can visualize this with a little shape here. As we move these numbers, we can see the shape start to change the geometry. And then we can write notes for ourselves if you want to keep notes in here with Scribble, which is right there. And then also some fun things like the parameter viewer to see, again, how data is flowing just in a different way. So it is there. I don't use this much. The main thing we'll be focusing on, though, is importing geometry to Grasshopper and then using sliders to put numbers in that we can move around. And then usually using panels to see what data is coming out. The rest here we'll get into with different workflows, but we have domains to set ranges of numbers at once. So like 0 to 1, 5 to 10. We can do some basic math, addition, division, multiplication. We can write expressions or actual code in here if we want to do that. I'm not going to be doing that. Yeah, it just gets kind of complex. We can do most stuff just with components to keep it more visual for designers. Averages, pi, series of numbers, different things we'll look at. So I think now we're in the sets tool. So some different items for affecting data structures, data trees. So we can input different items into different spots using the indices and the paths to define different movements, data, random values, some things for text. Yeah, concatenate. Did I hover over it? Yeah, it's an interesting word, but it basically just puts two different kinds of text together. So I could, change this and it'll update over there. Just pairing those things together. Might add a space in there. The merge block is quite important. As I explained, we could drag multiple wires into the same thing, but that can get kind of messy. So we could have a merge block that'll give us more inputs for more data. We can just keep plugging stuff in into one single output. Next week, we'll look at Voronoi stuff, and that'll have to do a lot with populate 2D, populate 3D. So we can get like random points in space. And then we can also populate the edges of meshes and things. We'll get into some of this next week. I was showing earlier like how to set just standard points. We can do that with XYZ values. We have things like closest point where we can actually find within a bigger structure, the closest point to something. We'll use this a good bit. Things to construct vectors, things to construct curves and break them down into points. I think we're in curve now. So you can look through and like read about a bunch of these. If you hover over some options too, it'll give you a breakdown of what it is.
Are we gonna share this?
Yeah, well, I can share this. A lot of this is just showing like what components are out there. Just because, typing the name in is so easy. It's good to like have an understanding of what's out there. But a lot of this doesn't really do much. It's just kind of showing components. But yeah, I'll at the end of class, I'll show you where like everything is going to be shared online. Some more things for curves into surfaces. We can, set surfaces, deconstruct them. Let's see, do I have a surface in here? Okay, so some things like this, I could set a surface and then move a point around that surface so we can see it's kind of reacting in Rhino over there. Some other options like lofting, constructing surfaces like we did before with 4 points, sweeping curves into another surface. Adding colors to things. And yeah, a lot of this, as I said, it's not doing anything right now, but just to show like all the different components out there. Here's the Voronoi, which we'll take a look at next class and do some structures like Sean, you had pulled up. Intersection things. So we have Boolean, but we can also find intersections of curves with other curves, curves with surfaces, curves with objects, objects with other objects. There's a lot here in this intersection tab. And then at the end, we have transform for moving, rotating, things like that. And there's a lot of components in all of these, but we're probably going to take a look at maybe 5–10% of everything that's in here because there's a lot that they have offering, but I'm not going to get into most of it. Yeah, I got a picture here. So that's yes, that's pretty good. Oh, last thing in the display window. So, we could set colors of objects. So if I had this and this, and then just hide that, and then it's not going to work like that. But, we can have like a blue thing, or we can change the color, change the hue. just to show in color. And then yeah, the last thing I wanted to look at with color is a cool thing like a point cloud in space. So I'm deconstructing that image into the different colors of it, but just some other visualizations for points that we can see, maybe, you know, a different colorway to see different points. It shouldn't crash because it's not. Okay, cool. Just to see like different ways to see color in here. And then the last one to look at would be a vector display. You know, a vector is a point and a direction. And by default, we can set a lot of vectors, which we will do, but they're not going to show up in Rhino. So in the display tab, there's a nice option to actually show a vector so we can see physically like which way this is going. It's just nice as visual workers in a design school to see what we're doing instead of just, you know, there's numbers somewhere doing something. Most of the workflows we'll see physically like what's happening as we start to change things in a workflow. Yeah, so that's the very, very condensed basics of like a bunch of the different components we'll be using throughout the semester. And then to show, let's see, where everything is going to be online. So I'll share this all with you, but we have a drive for the class. So I need to find, my Wi-Fi is slow. Okay, the Design for Dynamics Wearables folder. I have a bunch of Grasshopper files in here, and I also have the intro files from today in here as well. Should be an intro folder somewhere. Does anyone see it? Here it is. So this file is already up in here. So class 1 is all that stuff if you want to go back and look at this. But again, the file doesn't do anything. If you want to get super ahead, there's so many files in here. All of these actually do stuff. So you could download this. There might be plugins required for some of these, which it'll tell you if there is when you load it up. But you could download these, load them up into your Grasshopper and play with them if you want to see some other work. I think most of these are grouped by plugin, so they might not all work. The Voronoi, though, will work with stock Grasshopper. So, and we'll get into that next week. So one last thing for today. Let's see. Okay, so also in that file, and I'll put this in the GroupMe as well, but if you actually want to try to put together some of the things we learned today, which this should hopefully maybe make sense, but if you want to try to, you know, play with setting points, you know, dragging those into an object and seeing what it does, I have a couple Grasshopper definitions broke down here into just the parts with some descriptions on the side. It'll give you, and we'll try this out with the first few classes, but it'll give you a prompt like construct a line. So you could come in here and start setting points just like we were doing. With right clicking, we can see right click to set point. And then we can play around with, we'll need a point to reference. Let's see, so we could set a point. We could drag those together and start like building very simple definitions to get to this prompt. So construct a line. So it builds up in like, I guess, difficulty. So these are pretty easy, setting points, making lines out of that. The next one using sliders to do other lines. And then the last one, which if you can do it, cool. If not, no worries. But is actually making a ladder like we were looking at in some of the first things. So just using a few more components with other sliders, you know, to see if you want to test yourself and maybe put some stuff together, see how everything's working, just play around with the settings. You can do that. And I'll put this in the Discord. And we can see over here, if you remember with right clicking and previewing on and off, we can show up. This is actually, you know, what, if you were to put this together, what this would be doing. So the first one, you know, drawing a line, second one, drawing a line in a different way. And then the third one doing rungs of a ladder. So we can kind of see those different lines set up there. So you can preview these on and off to see what these are going to do. But I'll put this in the Discord. If you want to download it, play around with it, feel free. I'll be on the Discord if you have questions about it. You can ask me there. And the next class at the beginning, we'll take a look at this, and then we'll go into a Voronoi workflow. So again, Rhino Grasshopper computer should be set for next week. But, yeah. Everyone on Zoom, I'm going to stop the recording as well, but thanks for being here.